Good morning, everyone, and welcome to Bussmann University, a series of webcasts where experts from the Bussmann Series team cover today's most pressing overcurrent protection topics. My name is Shannon Stokes. I'll be your moderator for today's webcast. Today's webcast focuses on proper application of motor circuit devices, and our speaker is Bob Roy, Field Application Engineer for Eaton's Bussmann Series Solutions. Bob has been with the Bussmann division for 29 years and specializes in overcurrent protection training for OEMs and consulting engineers. He has done countless training sessions for IBEW, IAEI, IEEE, etc. He covers our Northern California, Colorado, Wyoming, Northern Nevada, and Hawaii markets. I'm pretty sure he covers our most beautiful territories. Throughout this webcast, you're welcome to submit questions through the Q&A chat window, and we'll do our best to get those answered before this webcast concludes. In the next day or so, you'll receive an email with a link to watch this webcast or any of our previous webcasts on demand. And when you're in there, be sure to check out our upcoming webcasts as well. I will now turn it over to Bob. Bob?
Thank you, Shannon, and thank you, Joe. Today's presentation is going to be on motor circuit devices, and here is the, hopefully everybody can see my screen. Here's the agenda. I'm going to go over NEC Article 430 motor circuit overview, and then we'll look at the commonly used motor circuit devices, and then a summary of common misapplications. So Article 430 covers motors, motor circuits, and controllers. It's made up of 14 parts, and motor circuit devices are covered in 4 of those. Starting at the top there, part Roman numeral 9, motor branch circuit and controller disconnects. Part 4, motor branch circuit short circuit and ground fault protection. Part 7, motor controllers. Part 3, motor overload protection, and again, Part 9, at the motor disconnect. So, here comes the most commonly used motor circuit devices used in industrial control panels and machinery. First one we'll look at is the UL98 disconnect switch. I lost the non-fuse off the picture here. Don't know what happened to that one. There's supposed to be 3 switches there. But picture a non-fuse switch right below the 2 fusible ones there. The one on the left is our compact circuit protector 2. It's shown with a through-the-door operator on its right side. It was developed around the cube fuse. Cube fuse has the smallest footprint of any UL power 600-volt fuse on the market. And so the switch that was developed for it correspondingly is the smallest UL98 disconnect switch in the market. Right to the right of it, with a blue handle, is a traditional Class J switch. The compact circuit protector is 45%, well, it takes up 45% less surface area on the back plane of a control panel. If you compare the height times the width, well, these are 200 amp switches, so some of the other amperages can go up to like 69% less, but comparing these 200s, it's 45% less surface area on the back plane of a control panel. You can get it with PLC, a monitoring accessory, auxiliary contacts. And this one is a, through-the-door operator. We're not showing the shaft or handle. Handle mounts on the outside of the enclosure. So the UL98 disconnects provide branch circuit disconnecting means, branch circuit overcurrent protection if fusible, can serve as motor controller and at the motor disconnect if horsepower rated, typically rated at 600 volts AC. The fusible switches have high short circuit current ratings with Class CC, CF, R, J, or L fuses. Short circuit current ratings typically 200,000 amps. The non-fuse switches can have high short circuit current ratings when protected upstream by Class CF, J, or L protection. can be used in feeder and branch circuits. Here is the motor circuit showing the UL disconnect functions. Again, motor branch circuit and controller disconnect, motor branch circuit short circuit and ground fault protection, motor controller on-off function. We didn't color in motor overload protection, but a fusible one could provide backup overload protection to the primary overload protection, which would be in probably a combination motor starter of there's several types of some kind. If you look on the left, I don't know if you can see my little arrow. That'd be nice if you could. The second device down, the first one's a disconnect down. It would be like a combination motor controller, which would provide short circuit motor controller and overload protection. So a fusible 98 disconnect switch could provide motor overload backup protection. We didn't color it in there, probably because some of them are not fusible, they're non-fused. Again, at the motor disconnect, that's article or part number 9 again. The next one here is UL 248 branch circuit fuses. And they provide branch circuit protection with class CF, J, RK1, RK5, CC, T, G, and L fuses. Over on the left, the first fuse is a class L KRPC fuse. The next one is a RK1 LPS RK fuse. The third one over is a class J. And the fourth one is a midget class CC LPCC fuse. And then the cube fuse is right underneath there. The square-looking fuse is the cube fuse. That's a class CF. These can come in time delay or non-time delay. The cube fuse with the yellow label is a time delay fuse, a TCF catalog number. We have a fast-acting fuse with a blue label on the cube fuse, and it's a SCF for fast-acting. Now the T fuse is a fast-acting fuse. The rest of them are dual-element time delay fuses. These provide full range protection for overloads and faults. They can serve as motor load protection. It's sized at 125%. We typically recommend using the RK5 for motor inrush time delay because it has the most time delay of any of the UL power fuses. Provides 248 fuses can provide excellent component protection. If we look at the LPS RK, Class J, and the CF cube fuse, with the 100 amp fuses with 20,000 amps of fault current available, the fuses will reduce that down to 3,000 and clear the fault in 4 milliseconds. Extremely current limiting, provide excellent protection. Very little energy gets through when the circuit's protected by these fuses. High interrupting ratings up to 300,000. The little CC is 200,000. All the other low peak fuses are 300,000. Rejection features are incorporated on current limiting fuses with 200,000 and 300,000 interrupting ratings. Now the Class J, Class L, J, and Q fuse are inherently rejection fuses in that their physical dimensions are unique. You can't put any other fuse in a Class L fuse holder. Same is true with the cube fuse and the J. Now the LPS RK and the Class CC LPCC fuse, there are other fuses that have the same physical dimensions but much lower interrupting ratings, down to 10,000. So we want to be able to reject those fuses with the lower interrupting ratings. So we have rejection features on the LPS RK1 and the CC. It's easy to see on the CC. There's a little hat or a little kind of a cap on the bottom. A CC holder will reject any fuse that doesn't have that little cap on there. So supplemental fuses with 10K interrupting ratings will be rejected by a Class CC holder. On the LPS RK1, the bladed version we're showing here starts at from 65 to 600 amps. The rejection feature is a notch in the blade. Now, the Class R holder, which is a rejection holder, R stands for rejection, has a, in between the one set of the clips, there is a pin that will block a fuse that doesn't have a rejection notch on it, like a Class H fuse, which is only has an interrupting rating of 10,000. So only a fuse with that notch will be installed, and those are all going to be Class RK1 or RK5 fuses. RK5s have an interrupting rating of 200,000. RK1 is 300. We can use these in feeders, branches, and control circuits. Here's our motor circuit for the UL248 branch circuit fuses. Provide motor branch circuit and short circuit with ground fault protection and motor overload protection. Again, we're going to recommend RK5 Fusetrons, FRNs, FRSs sized at 125% for overload protection. Fuse blocks and fuse holders, UL4248. These are not disconnect switches. These are just what they say, fuse blocks and holders. They're not to be opened under load or fuses removed under load. They may have bus bar accessories, like the device on the lower left has a 9-position array of modular holders. It's actually three-pole holders fed by at the top, there's a power terminal adapter. That's a 3-phase. You can get a single or 3-phase. This is a 3-phase adapter. So this comb bus in between the modular holders and the adapter is supplying 3-phase power to the three-pole holders. It says must match fuse class to the fuse block. So you can't put a Class CC fuse, shown on the left here, in a Class J holder, shown on the right and the top here. And so you have to make, we get asked once in a while, can we do something to adapt something like a Class CC into a J holder? You just can't do stuff like that. So you have to match the fuse class to the fuse holder. This is an innovative product here, power distribution fuse block. It combines a fuse block and a power distribution block into one product. Very space savings. You eliminate the space that a power distribution block would take up and the wiring to it. It's listed at $42.48. Could be an open style or with covers. Covers could have flow fuse indicators. Has feeder circuit spacing for UL508. Used in feeder and branch circuits, multi-motor applications. So you see on the bottom of the fuse holder, there's a 4-pole. That's actually a power distribution block. 4-pole distribution block right there. We go up to 6 poles, about 200 amps. We can use in feeder or branch circuits, multi-motor applications. Perfect for that. So the 4248 holders provide circuit and ground fault protection when they have the appropriate UL class fuses installed in them, and also motor overload protection. I want to go over take a stab at going over slash voltage ratings here, because some of the, especially a lot of the combination motor controllers have slash voltage ratings. So looking at in this window here, NEC 24085, halfway down it says a circuit breaker with a slash rating such as 120, 240, or 480, 277 shall be permitted to be applied in a solidly grounded system where the nominal voltage of any conductor to ground does not exceed the lower of the two values of the circuit breaker's voltage rating. And the nominal voltage between any two conductors, line to line, does not exceed the higher value of the breaker's rating. So here's some examples here. Slash-rated devices can only be installed on solidly grounded Y systems. So if we look at this highlighted in yellow Y system, a fault from phase C to ground is going to be 277, so that corresponds to the lower value of a breaker, 480, 277 breaker. Line to line would be 480, so that corresponds to that to the higher value, so we can use it on a solidly grounded Y system. Over to the right here, corner grounded delta, a fault from C to ground is going to be 480. So, and that's higher than the lower value of 277. So we couldn't use it on a corner grounded delta. Below it on an ungrounded delta, a line-to-line fault from like C to A is also considered to be a line-to-ground fault. So that would be higher than the 277, so we can't use it on an ungrounded delta. On the high-resistance grounded Y, these systems are used in industrial plants where they have a continuous process and they don't want it interrupted by a ground fault. They want to wait until a convenient time for them when the process is over to clear a fault. So they have a resistor to reduce, the resistor here is shown that they're connected to the ground, to reduce fault current. And they want to keep that fault current around 3 to 5 amps. Pretty much anything from 1 to 10 seems to be acceptable. But if we have a fault from phase C to ground, it's going to be a 277 volt fault, so that's acceptable there. But once you have a fault, continuous fault like that, the other two phases go to 1.73 times the 277, which is going to be 480. So now we have from phase B and phase A, we have a nominal voltage of 480 volts to ground. And so if there's a second fault occurs on A or B, then you're trying to clear 480 with a single pole on a slash-rated device. And slash-rated devices are not intended to clear line-to-line voltage with one pole. So we can't put them on a high-resistance grounded either. Next device we're going to look at is a UL 489 molded case circuit breaker. It provides branch circuit protection, provides disconnecting means, can serve as a motor controller, can provide overload protection if sized at 125%, and can be used as at the motor disconnect. They're typically not current limiting devices. They may have slash ratings of 400, for like a 480, 277. If so, they can only be used on solidly grounded Y systems like we just went over. Resettable per OSHA rules, 1910. OSHA and NFPA have almost the same wording for their rules on resetting a breaker or replacing fuses. There has to be an investigation to determine what caused the overcurrent that made the breaker trip or the fuse blow. And if it's an overload, they can be reset and new fuses can be installed. But if it's a short circuit, the investigation has to, you have to investigate the whole circuit to determine if there was any damage done to like conductors or components like a motor controller. And the actual device itself, like if it's a breaker, has to be evaluated to see if it's still appropriate for use. So before it can be reset. So if it's a short, a lot of things have to be done to investigate to make sure that resetting that breaker or reinstalling fuses is going to be safe. These can be used in feeder and branch circuits. Interrupting ratings vary with voltage on motor case circuit breakers. Here's an example here. This breaker has a rating of 65,000 at 240, 35,000 at 480. So we have to know basically what the available fault current is and make sure the interrupting rating is going to be high enough and make sure we're putting it on the right voltage if the system voltage is correct for the interrupting rating. Here's the motor circuit for the UL49 motor case circuit breakers. Provides motor branch circuit and controller disconnect, motor branch circuit, short circuit and ground fault protection, motor controller on-off, motor overload protection, if sized at 125%, and at the motor disconnect. The next device here is a magnetic motor starter. I remember the first time I saw a IEC motor starter, it was a long time ago. I thought it was a relay. It was so small compared to a NEMA back then. But these devices serve as a motor controller, on-off function. They're typically controlled remotely from like inside of a motor control center. They provide class 10, 20, and 30 motor overload protection. Class 10 protection is the ability to hold a 600% overload or 6 times the full load amps of the motor for 10 seconds. Class 20 will hold that same time delay of for 20 seconds of a 600% overload, and 30 will hold it for 30 seconds. These can be thermal or electronic sensing. The one on the right at the bottom, the overload relay, that is called a thermal pack. It's a thermal devices in there. And the one on the left with the yellow kind of a dial there, that's to adjust the electronic adjustment of the overload, and they can turn those up to like 14 times full load amps. They're a combination of a contactor and overload relay. Contactors are on top. They're called magnetic because there's a magnetic solenoid coil of wire that, when energized, will pull the contacts together to start the motor, and the contacts are spring loaded, so when it's de-energized, they'll blow apart. These can be IEC or NEMA options. Single motor circuits only. The short circuit current rating is determined by the specific upstream overcurrent device. It could be a type 1 or type 2 protection. Type 1 protection says the door won't get blown open on the enclosure for standard UL test currents. For high fault current tests, complete disintegration of the contacts is acceptable. This is considered type 1 protection. Type 2 protection says there will be no damage to either the contactor or the overload relay. This slide here compares a test with a type 1 protection. That's a motor circuit protector, magnetic only breaker, or instantaneous trip breaker, in other words. It provides type 1 protection, so pretty much protects itself, but it didn't protect the controller in this test. Over on the right, we have 30 amp Class J fuses protecting them, extremely current limiting. There's absolutely no damage. If you see the video of this, and if you look at, hopefully you can see my little arrow here. If you look at the little wires in between the fusible switch and the controller, you can detect almost a slight tiny movement if you look real close and put it in slow motion. So there's very little energy gets through with the Class J fuses protecting that controller, and that provides Type 2 no damage protection. Oops. Went too far there. The next device is a UL508 manual motor controller. Serves as a motor on-off function. Has to be located on the load side of a branch circuit protection device. Doesn't have any protection itself for overloads or shorts. It's suitable for at-the-motor disconnect. It's tested and marked accordingly. It's non-fused only. It can have high short circuit current rating up to like 65,000 when protected upstream with a Class J or CF fuse. Can be used in branch circuits only, can't be used in feeders. So here's the motor circuit for the manual motor protector. Motor controller on-off function, manual function, at the motor disconnect for local isolation. Next one's a manual motor protector, similar to the previous one, except this one has overload protection. Provides motor overload protection, serves as a motor controller on-off function, at the motor disconnect, only if located on the load side of motor branch overcurrent protection devices and marked suitable as a motor disconnect. If you want lockout tagout, you need to find a lockable handle accessory to put on it. The contactor is required for remote control, so there's no contactor associated with this device. Resettable per those OSHA rules for overloads and short circuits. And it provides on-off motor controller function, motor overload protection, and at the motor disconnect. The next one is an instantaneous trip breaker. Motor circuit protector, MCP, otherwise known as a mag-only breaker, magnetic only. It provides short circuit protection. It's permitted when used in combination with a motor controller and motor overload device, tested and listed for UL508. It provides motor branch circuit and motor disconnecting means, UL recognized, not listed. Doesn't have a standalone interrupting rating. It has a combination rating with whatever controller it's downstream of it that it's protecting. Limited to single motor circuits. Same resettable OSHA rules apply. And here's the motor circuit for it. Provides motor branch circuit and controller disconnect. Provides motor branch short circuit and ground fault protection. At the motor disconnect and at the motor disconnect. So those are the primary functions of it. Here's some different types of combination motor controllers. Type A uses a fusible disconnect switch for disconnect function and short circuit protection, and that's protecting a contactor and overload relay AC magnetic motor starter below it there. Type C uses a UL49 inverse time current curve breaker, providing short circuit protection, and also motor disconnect function. Type D, MCP, that's the instantaneous circuit breaker, magnetic only, no thermal overload element in it, and it protects that downstream contactor and overload magnetic motor starter. Type E, manual motor protector, also known as self-protected starter. It provides short circuit and overload protection and motor controller on-off function. Type F is a combination motor controller, provides the motor disconnect function, short circuit and overload protection, and motor controller function. The next device here is the combination manual motor controller type E, manual motor protector, self-protected. It's listed to UL 508 as a self-protected combination motor controller. Motor branch circuit and at the motor disconnect function provides branch circuit protection, provides motor overload protection, serves as a manual motor controller on-off function, requires use of line-side power terminal adapters to meet the spacing requirements for UL 508. It's typically a slash-rated device, 480-277, limited applications to solidly grounded Y systems only, resettable per the OSHA rules, 1910, use in single motor applications only. Here's the motor circuit for the combination motor controller type E, self-protected starter. Provides motor branch circuit and motor controller disconnect, motor branch circuit and short circuit and ground fault protection, motor controller on-off function protection, and at the motor disconnect. So that one covers all the bases there. F, combination motor controller, listed to UL 508, provides disconnecting means and at the motor disconnect, provides motor branch circuit protection, provides motor overload protection, serves as at the motor on-off function, includes contactor for remote operation, contactor underneath it here. Requires use of line-side power terminal adapters for spacing, typically slash-rated, limited to solidly grounded Y systems, and resettable per the OSHA rules for overloads and short circuits. Used in single motor applications only. And here's our motor circuit for the Type F combination motor controller. Provides the motor branch circuit and motor controller disconnect, motor branch circuit and short circuit ground fault protection, motor controller on-off function, motor overload protection, and at the motor disconnect. The next one is a variable frequency drive, VFD, speed drive. Provides motor overload protection, serves as a motor controller on-off function. The solid state power conversion piece of equipment, listed to UL 61800-5-1, provides branch circuit protection is provided by the indicated by the manufacturer. When protected by semiconductor fuses and motor circuit protectors, integral to the assembly. So the manufacturer will, if he doesn't have the protection inside his speed drive, will tell you in the manual what circuit protection needs to be provided upstream of the VFD. Provides a motor controller on-off function and motor overload protection. Obviously its main purpose is to control the speed of the motor and the torque of the motor. There's a soft start starter. Provides motor overload protection. Serves as a motor controller on-off function. It's another piece of solid state power conversion equipment. It ramps up voltage and torque. You don't have it's to avoid a across the line full voltage start that a lot of industries are try to avoid. Provides branch circuit protection required upstream as indicated by the manufacturer, or branch circuit protection is required upstream indicated by the manufacturer. The soft starter provides motor controller on-off function and motor overload protection. Here are other devices commonly used in the industrial control panels and machinery. UL-248 high-speed semiconductor fuses. These are permitted to be used for branch circuit protection of a motor circuit containing a variable speed drive whose installation instructions recommend its use. It's UL recognized, it's not listed. It has very high interrupting ratings, and they are extremely current limiting. These are for protecting solid state semiconductors like the IGBTs or SCRs in a speed drive, and very low I2T let through with of energy with these fuses. The next one is UL-1077 supplemental protectors. They must be located on the load side of a branch circuit protection device. They're UL recognized. They have low interrupting ratings, typically 10,000. They're not to be confused with a UL-489 molded case circuit breaker. They typically have slash ratings like 480-277 or 120-240, and they're used on control circuits. So supplemental protectors are used for specific applications, and they have to have a branch circuit protection above them, feeding them. They can't really protect themselves. So specific application could be a luminaire that requires that has been listed by UL with a supplemental protector fuse, or a protector like this device here. And again, it's for specific applications, and it has to have some branch circuit protection upstream. Used on control circuits a lot. UL-248 supplemental fuses. These must be located on the load side of a branch circuit protection device, like the supplemental 1077 device we just looked at. These are UL listed. The interrupting ratings and voltages vary a lot. They're application specific, used a lot on control circuits. Again, they must have some upstream branch circuit protection to use these supplemental fuses. UL 1953 power distribution blocks. These provide distribution of power. UL listed. They could be splicer or distribution style. These ones here we're showing are distribution style, where you have one big wire coming in and a lot of small wires going out. But they could be splicer style also, where you have one big wire coming in, one big wire going out. It's just like the function is just to splice two wires together. Finger touch safe or open style. The gray one underneath there, that's IP20 finger touch safe device. The one on top is the open style. You can get covers on a lot of those open styles, but even with the covers, they don't provide IP20 like the one below there does. The power distribution finger safe PDFS product has feeder circuit spacing for UL 508A. Can be used on feeder or branch circuits. Next product is UL 1059 terminal blocks. These provide distribution of power, UL recognized. Could be the splicer or distribution style. Typically they're typically open style, and they can also have covers. Branch circuit spacing, not feeder spacing. Cannot be used on feeder circuits unless investigated for compliance with UL 508A Table 10.2. Here's some common misapplications in control panels. Motor switches or controllers used as a feeder or main disconnect. Manual motor protectors used as branch circuit, short circuit protection. Fuse holders used as disconnecting means. Supplemental protectors, mini breakers or supplemental fuses used as branch. Insufficient overcurrent protection devices. This is a misapplication pretty much all over the place in our industry at times. Motor circuit protectors or instantaneous trip breakers used as branch circuit protection in other than type D motor controller combinations. UL recognized terminal blocks in feeder circuits without the required feeder spacing per UL 508A. Slash rated devices applied in any system other than solidly grounded Y systems. Like we went over the ungrounded delta, corner grounded delta, and high resistance systems, high resistance grounded systems can't use slash rated devices. This is going along a lot faster than I thought. Additional resources that we have in tools. The fault current calculator FC2 is this first, the handheld mobile application. If you go to our website, or if you go to your app store, I should say, and just type in Bussmann or maybe Eaton Bussmann, the first thing that usually comes up is FC2. There also could be sometimes a fuse finder may come up first, but it's very simple to get it, and it's very simple to use. For a contractor, he could be out in a plant somewhere, and he could, if he knows the information on the transformer and the conductors, he can put that information and find the available fault current really easily. And then he can print out a label of what the fault current is on the specific equipment, and that label can be attached to, say, service entrance equipment that requires a label with available fault current and the date it was calculated, and all that information would be on the label provided by. So basically, you send yourself an email from your phone and to your computer, and then you can print off the label. The SPD, Selecting Protect Device Electrical Protection Handbook, that's pretty much our Bible. It's a 300 and something pages, and it covers all the topics associated with overcurrent protection, like selective coordination, component protection, arc flash analysis, SCCR ratings, pretty much anything that's of interest in overcurrent protection is in that book. It's easy to get. If you go to our website and go to Bussmann, Eaton Bussmann, and you go to there'll be a little search window in the upper right corner. And if you start typing, don't type in SPD because you'll get a surge protection device to come up. But if you type in Selecting Protective Devices or Electrical Protection Handbook, you'll get a page drop down for that you can download this. That's probably the easiest way to get that. If you go to any of our, well, we haven't had them lately, but, any kind of a trade show or IEEE meeting or IAEI meeting, we'll always have a few cases of these SPDs around there. It's a very popular technical guide. There's also a condensed version of it if you don't want the big one. That's their fuselology technical guide here, right behind the SPD. It's a lot, I think it's more like 70 pages, but it's a condensed version of the SPD, and it has a lot of information in there also. So our highest recommendation and for motor circuit protection devices is specified low peak fuses, and our compact circuit protection or UL98 fusible disconnects for the highest level protection. The compact circuit protection is the smallest UL98 fusible disconnect on the market. The load break device, it's motor rated, and the cube fuse is the smallest power fuse on the market. I actually compared the area taken up by a cube fuse in its holder to a Class J fuse in its holder, and the cube fuse was like 15% the size. So I thought that might be wrong, so I went out to my garage and got a sample of each one and measured them, and it's accurate. They're those two products are extremely space savings. When you, especially that cube fuse, when you compare it to like a Class R fuse, it's a fourth the size. So anyway, I finished a lot earlier than I was expecting, but I guess I turn this back over to you, Shannon.
Okay, thank you so much, Bob. This is just a reminder that the Bussmann University, your access into that gives you the right to view any of our webcasts live at their day and time or on demand after live broadcast. So for all the ones we've done so far, those are available to you on demand. And then we have 2 upcoming webcasts that cover SCCR. You are welcome to join us live for those or wait to view them on demand following live broadcast. This concludes today's webcast. We'll give you back some time in your day. On behalf of the entire Bussmann Series team, thank you so much for your time. Have a wonderful rest of your day.
Yeah, thank you very much.